All right, so let's look at number 7 here. Oh, this is good. You know, it was kind of ironic. A block did not do this one, but then right at the end of the block, one of the students was asking me about how to do this one. So, we got two objects. One that starts at 25 meters and moves with a negative velocity, and another one that starts at 13 meters and moves directly towards the other one, and a time for them colliding. And they want to know what's the velocity of object 2. I'm going to assume in the frame of reference of the Earth, and what's the position of the objects when they collide. So, bless you. We're doing number 7 here, and so I'm going to start off. I am assuming the Earth's frame of reference. And then I think I need a picture. So one and two. Do they label 1 and 2? Yeah, 1 and 2. Very creative labels there, but we'll live. So this would be 0 meters, this is 13 meters, and that's 25 meters. That one's moving that way, that one's moving that way. Yes? That's the situation. I assumed positive was this way. Sorry, I should have asked you guys, but. And so what has to be true for the two of them to hit each other? Then what? Come on, don't be shy. They have to be the same place at the same time. They can be moving however they want, but so I'm going to show that I understand that in my y. To hit must be same place at same time. Now, did it tell me 13 was moving towards 25? It does. It did. Because could 13 be moving the other way and them still hit? Yeah. Yeah. But them coming together, I know I'm going to show that I understand this position will be between balls, objects. What do they call them? Objects? Objects. Because if 13 was going the other way, then it would be somewhere out, not between them. If the object 1 was going the other way, but with them both heading towards each other, the position will be between the objects where they hit. And I think that would hit it. I think that would do everything for my y. I've shown a clear understanding of the physics. I've sketched the road back to the house, so I've done some specific things to this problem, including my diagram, which will be included as part of my y. And I've shown to explain how the universe works, not how to solve it. I think I'm good on the rubric. All right, so let's go down to the how, and there's I put the rubric for the how just at the top so that I would keep it in mind. Where can I find my equations? On the equation sheet, and I haven't pulled it up, but I think I remember them off the top of my head. But you guys should have your equation sheet probably right here, that would be good. So I'm going to remember the equation that says D equals D naught plus V delta T. or something very close to that. My position is where I started, and my velocity and time, which combine to be how far I moved. All right? For them to hit, D1 has to equal D2. That's that be in the same location. And I'm not going to use like time 1 and time 2 because they're both going to be moving for the same amount of time. So I'm just going to use 1t, and that way it's common to them both. So putting this in for D1, if I can do all my steps, I do D01 plus V1 delta t would equal D02 plus V2 delta t. Can I cancel anything algebraically right now? No, because there's nothing common to every term. Would you be more comfortable if I manipulated this algebraically right now, or if I put in the numbers and then we did algebra? Which would make you guys mathematically more comfortable? Put in the numbers at this point? Okay. All right, so this was 25 meters plus negative 5.8 meters per second. Delta t was 0.62 seconds, equal 13 meters plus, I don't know what V2 is, that's what I'm looking for. It's always good to have one variable, and the same amount of time. So now I just solve for V2. Because everything but V2 is a number, right? Am I hoping for a positive or negative number? Well, let's see. Let's go back to our diagram. Is V2 moving in the positive direction or the negative direction? Positive. So I'm hoping for a positive number. If I get a negative number, I'll have to check my math. Most common math mistake will probably be forgetting that there's a negative in front of the 5.8. And I got 13.555 meters per second. Yeah, I got a positive number, so I'm pretty confident in it. Now, common mistake is if you put in 13 point whatever into your problem, you probably won't get it correct because you have different numbers than I have. So let's see, before I go on, I want to make sure that that works so I don't double my mistakes. And they ask for 3 sig figs. So it's going to be 13.6 for me because that 5 would round upwards. Yay! So now I can go on and answer that part B. So that was part A. Maybe I should label that as part A. And part B, they want to know the position. Now, if I was unsure, if I hadn't checked that number like on a test, so this actually I would write as 13.6. That would be my final answer, 3 sig figs. If I wasn't sure of that, I'm going to use this side to find that position because that doesn't count on if I made a mistake there. So I'm going to look for D1, and that's going to be the 25 meters plus negative 5.8 meters per second times 0.62 seconds. I got 21.4 meters. So that's the position that they end up at. Let's see if I got it right. Yep. Yay! Oops, I paused that there. So we're doing number 12. And so I would start off, since this problem is all about frames of reference, I would start off by something like all motion is relative to a frame of reference. So velocity changes when the observer changes frame of reference. Trying to think if there's anything else I really need in there about this. I don't think so. I would like to easily have my relative motion equations, so let's grab those. And then I want to go here. And which one is faced? All right, so I've got my relative motion equations. I wrote nice and neat. Let's see. I think I'm going to move my diagram. Well, we'll just leave that. We'll leave it up. Never mind. So they want to know what's the velocity with A with respect to B. So B is in the reference frame of the Earth, right? Right? So we can actually use this equation. So we want velocity, this is part B. Velocity of A with respect to B. That's going to be the velocity of A to the Earth plus the velocity of the Earth to B. And so we know this is 12, positive 12 meters per second. And this is 0 meters per second, right, from our diagram back here. Okay, you guys okay with assuming to the right is positive? Yeah, okay. And so I get an answer of 12 meters per second, positive. And let's see, is that one of my choices? Yes. Good. Oops. I always forget to have the pen in my hand. And then part C, what is B to A? Well, part C, I can use that the velocity of A to B is the opposite of, actually, we want B to A, is the opposite of A to B, using my second equation there, right? And so that's going to equal negative 12 meters per second. Remember, the negative means left. Correct? Yes? Makes sense? All right. Let's go on and look at D. Can you determine the distance between the Audi and the Buick? Well, do we have any information on distances? I'll let you figure that one out. What is A to C? All right. A to C. So we're on to E, part E here. Oops, forgot that. So we want the velocity of A with respect to C. And so we can do the velocity of A to the Earth plus the velocity of the Earth to C. So that would be A to the Earth was positive 12 meters per second, if I remember correctly. Yep. And C to the Earth was negative 15 meters per second. So that means that Earth to C would be positive 15 meters per second, using the same logic that we used in C. Right? So I should get positive 27 meters per second. And that's one of my choices, 27 meters per second to the right. So I'm thinking that that's probably correct. And then F, D to C. Velocity of D to C. And do it the same way. D to the Earth plus the Earth to C. I'm pretty confident you guys can fill in numbers for that, given the repetition. And C to the D, I think you can do. Car using Etzel also moving on the same stretch of road, but not shown in the diagram. It is known that from the point of view of the driver of the Audi, the Etzel is moving at 8 meters per second. What is the speed of the Etzel relative to the Dahmer? So we've got, this one we should probably suss our way through a little bit. So H, skipping a couple parts. So we have the velocity of the Etzel compared to the Audi is 8. The velocity of the Etzel compared to the Audi is it doesn't say which direction, does it? Interesting. And we want to know, that's E, we want to know DE. No, ED. Right? Yeah. So we could do that the velocity of Ed equals the velocity of EA plus the velocity of AD. Right? You guys are so, give me so much good feedback. Keep it up. Do I know EA? That's a good question. Do I know? I do know EA. Do I know AD? I could figure out AD, right? Because I could do the, I want to move, let's see, I want to move this over. I could do velocity of AD equals velocity of A to the Earth plus the velocity of the Earth to D. Right? Problem is, EA could either be 8 or -8, because it doesn't tell me what direction, right? I think at least. They may have meant to the right as positive, but I'm not sure. So this one, let's see, A to the Earth was positive 12. E, Earth to Dahmer, E to D, is the opposite of D to E, so that's going to be positive 20. So A to D looks like 32 meters per second, positive. So I'm going to have two answers. I could have positive 8 plus 32 meters per second, giving me 40 meters per second. Or I could have negative 8 plus 32, giving me 24 meters per second. Do they give me choices like that? Oh, look at that. They give me choices like that. Any questions? No? All right. All right, so we're going to go with number 1 at a good pace so you guys can do, actually. All right. All right, so number 1. It may not have popped up yet. It may pop up in a minute. I can't remember what time I said it to pop up at. So, we got a billiard ball traveling in a positive direction, rebounds in a negative direction, and comes to rest behind its original position. And the questions are about distance and displacement. So, this is number 1. Number 1. So I would want to show that I understand what distance is. You know, distance is the length of the path traveled. And I want to show that I understand that displacement is how far I end from where I started. And I might even want to say, you know, displacement is a vector, so direction is important. I'm going to draw myself a little diagram. A little cushion. This is the start. That's the end. I'm going to assume positive is in that direction. I'm going a little quick because I want to. Now, nicely, they gave me things in centimeters and asked for me in centimeters, so that's 21 centimeters. That's 9 centimeters, I think. Yeah. All right. Yes?
Why is it 21?
Because my numbers are different than your numbers. Hence why I can sit in front and do the problem and you can't just copy it. I like it. Alright, so down here explain the situation mathematically. That ever precise language. Which one did I ask first? Distance covered by the ball, which I know is the distance is the total length of its path, so its distance, well, it goes two segments, D1 and D2. D1 was 21 centimeters, D2 was 9 centimeters, so it looks like my distance, if I can do it in my head, is 30 centimeters. B, displacement, delta D, D2 minus D1. So it ended up at negative 9 centimeters. It started at 0 centimeters, so its displacement is negative 9 centimeters. Ta-da! Yeah. We forgot here. We forgot the rebound. So it went 21 down and 21 back, and then 9 beyond where it started. For me, 51.0 centimeters. I blame it on Monday morning. The way to find the room name